Okay, today we are exercising the demand curve, and then the following lecture will be concentrated to the supply, and then we are going to introduce the elasticity. But now we have the demand curve, the substitution effects, and income effects will be introduced to you, the consumer surpluses, and of course concentrating the construction aggregate demand. The individual demands, and as you are aware of, the demand curve is mostly concentrated on the curve you are observing here. When the utility curve tangent to the budget line, this will then satisfy the optimal bundle for the consumer. The income consumption curve can be realized by using these curves. We are considering here all the variables remain constant. As much as the income is increasing, the expected utility curve will be shifted to the upward, as you are observing here. The income increased 40 to 68, then to 92, then the utility 1 to U2, and then U3. The income consumption curve will be expanded and enlarged. When we are concentrating and of course combining these three intersection points where the utility curve is tangent to the budget constraint, we are realizing the income consumption curves. When the income change, what is happening? Let's look up this. As you are observing, it is shifting to upper level. As you see here, shifted to the upper level. Every next development is expected that the income is increased, and of course the bundle, the Y and X combination units will be enlarged and increased, as it is indicated on this curve. If the price of the X is constant, then it's expected this is expected and enlarged in the horizontal level. The angle curve, when we are looking to the income consumption curve for the good X, can also be written as the quantity consumed of the goods X for any income level. This is the individual angle curve for good X. This is the angle curve for the first combination of X and the income, the second level for the X and the income, and the third level, as we have exercised in the former budget and utility curves. And when we are intersect each other, you see the angle curve is realized here. When the slope of the income consumption curve is positive, then the slope of the angle curve is also positive. The slope of the income and consumption curve must be positive for realizing positive angle curve. For the normal goods, when we are looking to the angle curves, how it is, the income curve is supposed to be more purchased, consume of X is expected to income rise, and good is supposed to be normal good. As much as the consumer purchases more, the X becomes, then the income is supposed to be expected increased and cause more consumption. This is supposed to be normal goods. If the slope of the angle curve is positive, the good is supposed to be normal good. For the inferior goods, if the income consumption curves results of the income increase becomes lesser, the consumer will buy less, then this is supposed to be inferior goods, as you are understanding. This is then of course the negative, as the normal goods is realized. A good can be normal over some ranges of income and inferior over others. Therefore, angle curve is negative. The good is then is supposed to be normal. Backbenching edge angle curves, as you are observing here, as much as the budget constant tangent to the indifference curve, we are realizing the angle curve at that level where it is tangent. Then we are illustrating this income and of course quantity both on that level. As you are observing, when it is increased to the upper level, then we are intersect the same combination for the next angle curve and for the third. And when it is backward, then what is happening? Income consumption curve is of course reduced because of the negativity, and the angle curve is also directed to negative level. Individual demands when the prices change. There are two effects: the income level, if it is changed, what will happen, and the substitution effect, where the goods change and affects and the change the combination. Let's have a look at this. The income, when the price of goods fall, the purchasing power rises. This is then supposed to be income effect. Of course, ceteris paribus, all remain constant. The income effect can be or may be positive for normal and negative for inferior goods. The substitution effect, similarly, when the price of good falls, become cheap. This is then, of course, relative price along causes the consumer to adjust his consumption basket. This effect is called substitution effect. It assumes all else remain constant in these two examples. The substitution effect is always negative. It's supposed to be negative. Usually, a move along demand curve will be composed of both effects. Let's analyze both effects for normal and inferior goods. For the normal goods, as you are observing, the budget constant will be tangent to the utility form, utility curve. The slope is negative, of course, px1 over py. And results of this, when the price changes, it is expected that xc is expanded and enlarged. This is an overall effect supposed to be expected. The first expectation or change on the budget constant and of course utility. But this is not the neither income nor substitution effect. This is the overall effect of these changes. When the market settled, then of course it is expected that the consumer's utility realized on the same curve. As you are observing, it is shifted to the B, and of course XA not going to XC but is reduced to XB. This is then of course substitution effect. Income effect is observed here when the XC between XC and XB. This is then, it first goes to C and then goes to B, as you observe here, you see. And then overall effect, as I said to you, the first action from XA to XC. Then this is an overall effect. If then the moves back from B to C, from C to B, is then of course income effect. And when it is moved from A to B, results of this price changes, then it is of course expected to be the substitution effect realized for the normal goods. For the inferior goods, when we are looking on it, as you are observing here, it is moved from XA to XC. The slope of this curve is again minus px2 divided to py. As you are observing here, it is then of course expected to shift on the same utility curve and comes to the xb on the same curve. And of course this is then of course xp, xa, as you observe, is the substitution effect. which is shifted to the reduced, and of course come to the similar utility curve, and budget constraint is a little bit shifted to the lower level. And income effect, of course, XC, XP, as you're observing here, XC, XP is then results of the price reduction. This has happened. And overall effect is, of course, XC, XA, as it is mentioned in the first action that we observed after the price changes. Realize this is for the inferior goods because it is not expanding the economy, because it is inferior goods. It is not expected to expand as in the normal goods. Realize it is reduced and less than B. We are bringing the market to the desired level. The Giffen paradox is, of course, theoretically, it is possible that for an inferior goods, the income effect dominates the substitution effect. How it is realized, let's have a look again to this. A given good is a good that is so inferior that the net effect of decrease in the price of that good, all else constant ceteris paribus in these conditions, is decreasing the consumption of the goods, as you are observing here. Let's have a look on the graphic. The income effect and substitution effect for given goods. You see? Now it is reduced because it is given. It is moved to C where it is less than expected. This is because when the income increases, you are not consuming any more of this goods, and you are, of course, probably directing your consumption to the others. Then XA, XC is the overall effect. Then when we are, of course, bringing the market to the expected level, this will then comes again on the same utility where the budget line intersect, as you are observing here. The slope is again P minus Px2 over Py, bringing the market to the equilibrium level. And of course, the optimal bundle is realized for the given. This is then, of course, supposed to be the overall effect. This XC, XA is the overall effect. The substitution effect realized XP, XA, XP, XA is the substitution, and income effect is the XC, XP. XC, XP, this is then, of course, income effect, where we are realizing the new intersection of tangent to the budget line of the utility curve. The given goods demand does not slope down, as you are observing the important points. For the income effect to be large enough to offset the substitution effect, the good would have to represent a very large proportion of this budget, as you are observing here. Let's look up this example as we are giving for finding the income and substitution effects. Suppose the utility function is given as u is in bracket x, y is the 2 root square x plus y is the marginal utility. X is equal to 1 over x root square is the marginal utility, and of course for the, as you are observing from the function, marginal utility for y is 1, because when you get the derivation of the first y is 1. Then the Py is €1 and income is 10 euro. Let's have a look up this on the example. When it is estimated, then you are observing here, when we calculating marginality x over marginality y is equal to px over py. This is then the well-known equation, so-called, is then calculated as XA4, and when we are putting this into the equation for budget constraint, then it will give us the income as 8. And then calculating the utility level is, of course, when you are observing, when we put the equation 2x root square plus y is then, of course, 12. Then the YA is 8, x is 4, and income is, of course, given in the first example. Then we will calculating. Suppose the x is 0.20 now. When it is then, of course, you are having the xc as 25 and y 5, and the utility level is, as you are calculating from the given equation, is 15. What are the substitution and income effects for the given example for the PX? Find the basket B that gives the utility for 12 at price 0.20 and PY for 1. Then when we are illustrating on the graphic, as you are observing here, the first utility was 12, as you know here, you see. This was 12. Because income is 10 after estimating, you see. When the price of this X shifted from 0.50 to 0.20, then of course utility level to change on the curve to 15. Then we are shifting from A to B, then B to C, because of expected overall effect is XC, XA, XC, XA is realized, and income effect XC, XP, XC, XP as you observe here on the B, and of course substitution effect is then realized XP, XA. XP, XA here then is of course shifting the equilibrium to the next level, or let's say to the optimal bundle. The tangent condition, as you are observing here from this equation, we are estimating is XP 25 and the utility is 2. The substitution effect will be calculated as then XP minus X2, XA, sorry, 25 minus 4 is then 21, and XC minus 25 minus XC minus XP, then 25 minus 25 is then 0, then income effect is 0, and substitution effect is expected to be 21. When we are looking to the consumer surpluses here, the consumer surplus, as you are understanding, let's look up this figure on it. The figure, let's figure up this the figure. The consumer surplus is this one, this area. As much as the price goes up, the consumer surplus here is supposed to be reduced. You are understanding? Okay. The consumer surplus is the net economic benefit to the consumer due to purchase of goods. It is measured by the difference between the maximum amount of consumer is willing to pay and the actual amount of he pays for it. The area under the ordinary demand curve and above the market price provides a measure of consumer surpluses. When we are looking on this explanation, the consumer surplus is of course can be calculated by the given equation. Q is equal to 40 minus 4 px, and suppose px is equal to 3 euro. What is the consumer surplus? Let's find first the px on the curve, then we are estimating the q, then of course estimated for the given amount. You see, this will be then for the 3 area multiplied 0.5 multiplied 10 minus the 10 minus the 0.5, and of course because this is not a square, this is a triangle, and multiply with 28. You see, think about this as a square, or you have to divide, or you can calculate this as a height based divided 2 for the triangles. Then you find the area for the consumer surpluses. What if px is reduced to 2? Then this then enlarged surplus, as you are observing here. Again, then we are going to use the triangle equation, height multiplied base divided 2, 0.5, 10 minus 2 divided 2, multiplied to 32. As you see, the surplus is enlarged here from 2 to 3. This is then the surplus amount. We can calculate also the enlargement on the surplus, but not necessarily. The market demand function is the horizontal sum of the demands of the individual consumers. In other words, the market demand is obtained by adding the quantities demanded by the individuals at each price and plotting the total quantity for possible prices. As you are observing here, the Q1, consumer 1, consumer 2, and market demand is shifted to the, suppose we have two consumers as shown here. This will then combine on the same graphic for the market demand, and this of course expanded and shifted a little bit higher level when we are adding each other and enlarging the aggregate level of this. Okay. We have summarized the today's lecture. We exercised the substitution effects and the income effects, and of course question the budget line and budget constraint and utility, and introduce to you a simplest application. Next lecture, see you.